All right. Welcome to our password policy review for the My University of Georgia. My name is Alex Young, and the rest of the team tasked with this review is Phil Ezell, Dee Wilson, and Wes Wilson. So, as you know, you tasked us, your team of cybersecurity experts, to investigate the following regarding password policies and develop a white paper you can deliver to your colleagues. You wanted us to look into the best practices, current academic and relevant research, and then relevant government organization policies and procedures.
Okay, so now I'm going to discuss some of the government recommendations and policies. So, the government uses standards from the National Institute of Standard and Technology. They issue guidelines and standards for areas such as password security and authentication. The NIST Special Publication 800-63B are a part of the NIST Digital Identity Guidelines. So those guidelines are what we use to create a better password or security for the passwords. So we like to focus over on the password length versus the complexity. Complexity causes issues because users get lazy or they try to create easy to remember passwords. Um, Another recommendation is the passphrase. So instead of using passwords, we suggest that you use passphrases, which are a sequence of words or other text that is typically longer than a password and more secure. And you can use a maximum of 64 characters. And then the government also advises against mandatory frequent password resets. Now, forcing resets of the password will often lead to users becoming lazy again and creating inadequate passwords. So, therefore, we don't suggest that you force a reset unless it is mandatory or suspicious that suspected of being compromised. So if the password is compromised, then you can change it. Otherwise, we suggest that you leave it alone until maybe a year or so. A good application to have is a password manager. Now, a password manager is a software application designed to store and manage online credentials in one convenient location. So therefore, as Phil said, it'll take the human element out of the password process. And that will result in a more secure and less vulnerable password. Also, password managers can generate a password for the user. It can store the password and can eliminate users repeating passwords for different applications. So when you use passwords across applications, it becomes easier for a hacker or bad actor to guess that password. And then the password manager also let the user know if it is identified in any breaches. So password managers have the ability to analyze your password against known data breaches, and that will uh, eliminate the excuse me, and that will eliminate security issues. So if you know that the password was used in a data breach, you can change that password to a more secure and efficient password. All right, and I'll pass it on to Wes.
Thanks. So within the industry, um, there are a couple organizations that have come out with their own recommendations for a password policy. OWASP is a open web application security project um, dealing with um, web application security. And they recommend a minimum length of 8 characters, as well as Microsoft's password policy recommendation. Um, OWASP recommends a maximum length of 64 characters, whereas Microsoft doesn't particularly explain that. Um, Pretty much everybody suggests to look up a common or breach password and verify that your password is not in that breach corpus. Um, Nowadays, they recommend against having composition rules. This is a relatively new update to password policies, as well as not rotating passwords. And we heard that in the NIST guidelines also. And then they also suggest multi-factor authentication. And the University System of Georgia has not updated their password policies to be in line with most of the NIST guidelines or OWASP yet, but eventually they'll get there. So why is password complexity necessary? Well, passwords are stored using hashes. So no encryption or plain text should ever be used to store a password. And fast hash algorithms such as MD5 or the SHA family of hashes should not be used either. Only things such as like bcrypt or PBK-DF2 should be used. So what are the attacks on passwords? Nowadays, most of them are, they start with dictionary attacks from like known breach passwords. And then after that, brute forces can be done with like hundreds of GPUs in a cloud. So it is very important to have a very long password. It makes it exponentially more difficult to crack. So here you can see this is on a 3090 NVIDIA GPU. So if you look at the next to last column, that's a password complexity of numbers, uppercase letters, and lowercase letters. And you can kind of see like for a 8 character password for an MD5 hashing algorithm, it only takes 52 minutes or an hour to crack it. Whereas if you have like a 15 character password, it would take 251 million years. So it's very important to increase the complexity of your password and increase the length of your password. PBK-DF2 is a stronger password hashing algorithm. So if we look at the 8 character one again, it would take 2 years to crack the same password. And then we go to the next slide. And then bcrypt is another one that has a work factor that you can increase the work factor. And it would take 72 years to crack like the same password. And then this is just, and then the last image is just to show for breach passwords, it is pretty much instant that your password would get cracked. So it's very important if your password's in a breach corpus to never use that password ever again. And yep. I think that's Phil.
Yes. All right. So another approach to addressing some of the password authentication concerns is to centralize the sign-on process, and this is referred to as single sign-on. This process has grown in organizations as services and systems have grown in the organization, and the two have coincided. The need to authenticate, obviously, with multiple systems has also increased the need to solve the problem that we're discussing today. This growth has also been enhanced by things such as password fatigue, adoption of cloud services, the need to support enterprise mobility, and a more mobile workforce. So we asked the question, what is single sign-on? Simply put, single sign-on is a cybersecurity approach for authenticating users across multiple systems or applications by using a single username or password combination. In other words, this means a user is able to log in or authenticate in one location and then access multiple systems. So it centralizes the process of logging in and then allows access to the systems that are supported by that particular provider. It works by a trusted relationship between a service provider, which would be the application, and an identity provider, which would be the single sign-on system. A user would need to access the particular supported application. They would first authenticate with the identity provider, and then the identity provider would direct the user back to the supported application where it would allow access. In the background, of course, there are some things happening that are not apparent to the user. This trusted relationship between the identity provider and the service provider is taking place with, in many cases, with a token that's passed from the identity provider to the service provider, and then the service provider is able to authenticate the user based upon that. And that token will often include information about the user and, of course, whether they're authenticated and allowed to use the supporting system. Some advantages of single sign-on are, one big one is the ability to scale quickly. By centralizing the credential management, it allows the ability to add multiple systems so organizations can easily grow and still manage credentials. It also centralizes the credential management, which reduces the number of passwords that users need to remember. And to Dee's point, that allows you then to, and really Wes as well, to increase the complexity of the password and strengthen it, which thus increases security. It also can lead to productivity in that users are not having to log into multiple systems multiple times a day. They're able to log in one location and then access the systems that they need access to. A final advantage is the ability to disable users across multiple systems. By centralizing the credential management, you can disable a user, and then, of course, they would be disabled in all supported systems. Single sign-on is not perfect. There are also some disadvantages associated with it. One, which is probably obvious, is it provides a single point of failure for all the systems that depend upon it. So should a bad actor gain access to the credential, the identity provider, or gain access to those credentials, then of course they would have access to all the systems that those credentials provide access to. It's also can be complex and expensive to implement, so organizations need to consider that when looking at a single sign-on solution. And then one additional single point of failure, should the identity provider fail, then users would not have access to any of the supported systems at the same time. So, and I think that's it.
All right, thanks, Phil. So I'm going to cover multi-factor authentication briefly. And multi-factor authentication is essentially a methodology that requires users to provide more than one factor of verification to gain access to a secure resource, such as an application or online account. And so usually it's comprised of something you know, such as password, PIN, and city of birth, combined with one of the other two categories you see here, something you own or something you are. Something you own can be smart cards, tokens, driver's license, mobile phone, other things similar to that. Something you are would be your characteristics such as fingerprints, facial recognition, retina scans, that sort of technology. So common implementations of multi-factor authentication are, one is physical access cards. Now, physical access cards for the university environment is not recommended, mainly because of the high turnover of students and trying to manage physical hardware, tokens, USB drives, that sort of thing that would need to be mailed out and provided to the users. With them constantly changing in high volumes, it just does not make a lot of sense to go that direction. But that is one form of multi-factor authentication to be provided. Another one is SMS or text. And now this one is one of the most widely adopted versions of multi-factor authentication. And it's really simply because most Americans have a mobile phone. Not every American has a smartphone or utilizes the smartphone features, but almost everyone can send and receive text messages. And so with SMS, you would attempt to log in using a password. It will send you a one-time passcode back to your mobile phone, the one that you registered when you created the account, and then you'd be required to put that that information in, whatever that passcode is, into the system to verify that you're in possession of the phone and therefore should have access. And another one, I'm not going to go in depth on, but time-based one-time password apps. Essentially, you have some smartphone apps that synchronize a secret key generated from a provider, and then a verification code comes out of that application, and the server uses the same methodology on its end to verify that that code provided by the app is the same. And these codes usually only last about 30 seconds and are only good for about 30 seconds. And so it really is a difficult technology to crack. But again, it does require users to have a smartphone and utilize that aspect of their phone in order to do this. So everything that we presented here, we'll go through the recommendations now. What our team recommends is that you reduce the composition complexity of the password. And, you know, as discussed, overly complex password composition policies lead to poor behavior by end users. We would recommend dropping a composition policy altogether, but that would put us out of compliance with the University System of Georgia. So currently, the current password policy requires 3 out of 4 classes of characters to compose a password. We recommend reducing that to 2, only requiring characters from 2 categories to stay in compliance with the University System of Georgia. Increasing the minimum length to 10 and the maximum length to 64. This is a combination of industry recommendations and, again, meeting a minimum requirement by the University System of Georgia. They require at least 10 characters. So even though the industry recommendation is a minimum length of 8, obviously we need to stay in compliance with the University System of Georgia. Other recommendations are screen new passwords against common passwords and compromised passwords that have been in a breach. And you can use a service such as Have I Been Pawned to look that information up at time of password creation. Encourage users to utilize a password manager to help with password fatigue. And then ultimately adopt multi-factor authentication, which was just discussed. And then we also recommend adding single sign-on to help with management of accounts and reduce the number of logins that users have to remember passwords for. Please note that the University System of Georgia requires that if you implement single sign-on, you must have multi-factor authentication enabled. So if you do indeed implement single sign-on, then we will need to have multi-factor authentication combined with that. Any stored password should be hashed using bcrypt. As you saw from the charts earlier, it makes a password with a length of 10 characters that's just comprised of upper and lowercase letters. Difficult to crack, something like 47,000 years. So obviously hashing the passwords with bcrypt and requiring a minimum length of 10 characters will create a very hard to crack password. And then do not require password changes more frequently than once per year. Force users to change passwords if a data breach is suspected to have occurred. Now, the industry standard really recommends not forcing users to change passwords ever or until a breach has occurred. However, again, the University System of Georgia requires that you have users change passwords at least once every 365 days. If multi-factor authentication is not enabled, there are some additional requirements that require rotating passwords more often. So again, this is another reason to implement multi-factor authentication so that we can reduce the number of times passwords need to be changed. So in conclusion, we just thank you for this opportunity to discuss our findings with you. We believe the recommendations we have provided in the accompanying white paper with an appendix attached, which is revision 5 of the password policy, will help increase the security of my University of Georgia system. Thank you.